Now let me do this integral by three methods. They are all very basic, and this is a really good example for basic training to do the integrals. Method one, I'm using substitution method. So I use let theta be arcsine x, because arcsine x is an angle. So I use this theta for that angle, and therefore x is equal to sine theta, right? And this integral becomes theta square, right? D theta, d sine theta. As easy as this. When x equals 0 is 0. When x equal to 1, this is half pi. Okay? Good. Then I can use by parts. This one is equal to, this is u, this is dv, right? So equal to u v from 0 to half pi minus integral v du. V is sine x. Du is 2 theta, d theta. Okay. So this one is equal to, when theta is half pi, there's 4 pi square over 4. Pi square over 4. This is 1. So this is pi square over 4 minus 0. Now this one I can reorganize. This is 2. And from 0 to half pi theta, sine theta d theta, sine theta is a negative d cosine theta. Right? I change it to this one to positive. It's negative. Okay. So I can use by parts again. So this is pi square over 4 plus u dv, right? U v. Yeah. Minus v du. V is a cosine. Du is a d theta. And this one is equal to pi square over 4 plus 2. This is, right? This is half pi. Half pi is 0, right? 0, yeah. Minus cosine pi is 1, right? Yeah. This one is a sine, right? That's easy. And this is the result is a half quarter pi square. This is 0. This is minus 2. This minus 2, right? And plus 0. I made a mistake here, right? When this is 0, I forgot a 0 here. So this is 0. This is 0 times 1, so this is 0. So the result is pi square over 4 minus 2. Okay. Excuse me because this is 0, right? Therefore, this is 0. This whole term is 0. So this is the result of my integral by method 1. Now method 2, sine arcsine x square dx. Now in method 2, I'm using by parts right away. This is u, this is v, this is u, this is v, right? So this one is equal to uv, uv, this is u, this is v, right? Arcsine x square times x from 0 to 1 minus v du, integral from 0 to 1, v is x, v is x, u is a arcsine square, so du becomes 2 arcsine x and d arcsine, right? Yeah, d arcsine is this 1 minus x square dx. Yeah, good. I must be very careful because it's very easy to make minor errors. So this one is equal to, this is equal to, this is equal to half pi, right? Square. Half pi square is pi square over 4 minus 0. Okay. And this one, if I organize again, this is 2 integral from 0 to 1 arcsine x. And x dx, this one is equal to d this. Right. This derivative with respect to x is equal to this, right? Minus 2x dx. That is this. And 2 to cancel out, equal to negative x dx square root of 1 minus x squared. Well, I do have x dx over that, but I don't have a negative, so that changes the sign into positive. So that makes equal. Yeah. Then this one is equal to pi square over 4 plus 2. Now by parts again, this is u, this is dv, right? So u v minus v du. v is this. Du is this dx, right? So just cancel out. So this becomes 4. This is 1 is a 0, right? 0 is also 0. So the whole term is 0. And this minus 2 from 0 to dx. So this is equal to half pi square over 4 minus 2. Yeah, that is the same answer by using the second method. These two methods are very basic training for integration. So it's a really good example. Now, the third method This is the equation, right? This is the equation from 0 to 1 arc sine x squared dx. Now this method has a little complicated. I'm using triangle. This is theta. This is x. This is 1, right? Therefore arc sine x is theta. Yeah. Now this angle is a phi. Phi is equal to arc sine. This side is 1 minus x squared, right? So that is arc sine phi. We know that theta plus phi is equal to half pi. Well, when x is between 0, when x is positive. So that is the relation between these two. Therefore, both sides is squared. So this is square plus this is square plus 2 theta and phi is equal to, right? Both sides is squared. Therefore, from which we can find, well, let me change the line. This is square is equal to this is square over 4 minus phi square minus 2 theta phi. Well, this one is equal to pi square over 4 minus phi is a half pi minus theta. So this one is equal to quarter pi square minus phi square. This is a pi, right? Minus pi theta plus 2 theta. Okay, therefore, I move this one square to pi square. I move this one over there. Therefore, theta square is equal to negative that, right? Isn't equal to negative quarter pi plus phi square and plus pi. Yeah, I must be very careful. Yeah, so far so good. I move this one over there as a negative, right? Change the order sign, become this. Therefore, our integral, well, this is I, right? Our integral is this integral, right? I is equal to integral from 0 to plus integral of this. This is arc sine 1 minus x squared plus pi 0 to 1 arc sine x dx. Wow. Yeah. Now let me do separately by one. This is okay. This, okay, I don't skip. Okay, this is equal to, this is negative quarter pi square plus I1 plus pi I2. Now I1 is equal to this arcsine 1 minus x square dx, right? Forget a dx. And I use a substitution method. T is equal to 1 minus x squared. Therefore, x is equal to this. Yeah, that's correct. And then this is this will be arcsine t squared, right? And dx will be d, this. Yeah. When x equal to 0 is 1. When x equal to 1 is a 0, right? Yeah. And this one is equal to, I switch the order, have a negative, right? So it's a negative. I switch the order, it becomes a negative. Now, and this is U, this is V, right? This is a V, this is a U. From 0 to 1 has been switched, okay? Minus become plus, 0 to 1, this, and this derivative would be 2 arcsine t and dt over 1 minus t squared. So that's a VDU. Okay, and this one is equal to, this is 0, this is 0, the whole term is 0, right? This is 0, this is 0, yes. Plus twice, this is cancel out. 0 to 1, arcsine t dt. Yeah. This is my I1. This is my I2. I can combine them, okay? Therefore, I is equal to negative quarter pi square. This one and that one combined, right? Combined becomes 2 plus pi integral from 0 to 1 arcsine t dt. Well, t and x just dummy variable. Yeah. That one's easy. This one is easy. We can use it by parts, right? T arcsine from 0 to 1 minus v du. V is this. V du. Yeah, this one is equal to half pi minus this one is negative this one is a negative negative become positive, right? This integral is this negative. So this one is equal to half pi minus 1. Yeah. All right. Then we place this one here. Okay, this is this, right? Therefore, I is equal to negative quarter pi square plus 2 plus pi times what do we have? See? Better than here. What we are doing here is this. So this one is equal to plus this one is pi minus 2 and plus half pi square minus pi. It's amazing. This is equal to pi square over 4 minus 2. We get the same result. Well, this method is a little long, little complicated, but anyhow, it's a method. It's another method for learning purpose. It's good to practice. You will be benefit from it. Thank you for your watching.